So we should be live right now. Then, well, thanks everybody that is watching that online. I see that there is now 14 people connected. Later on, we'll probably get more. So yeah, again, thanks for everybody for coming here. Thanks also Florina and Jossi for making time for this meetup. As you may know, Florina Muntenescu is a developer advocate at Google, focusing on Android and Kotlin. And Jossi Wolf is a software developer at Snap Mobile. And I'm the organizer of the Kotlin Meetup and software developer as well. Today we have 3 sessions. Florina will be talking about how to manage async tasks in Kotlin. Jossi will be speaking about LiveData to flow migration, and I will be talking about what's new in Kotlin 1.4. If you have any questions, feel free to write them on the YouTube. We'll be able to see them. I see that some people is already writing. Yeah, the beer game is strong. That's the quarantine one. And we might respond as we read the comments or later, but don't worry, we'll have access to them. If there is any concrete question, just feel free to write it there, ping me on Twitter or on the Meetup group, and I'll let the other speakers know as well. So I think we can proceed. Florina starts first. So the stage is all yours, Florina.
Hey, thank you. Okay, let's see how I do this. Let me share my screen. Okay, I think the screen should also appear soon. Okay, there we go. So coroutines. I think especially in the last few weeks, we've been speaking a lot about Android 11 with 11 weeks of Android and the fact that Android 11 is now in beta. And well, Android 11 offers a bunch of new features, but apart from features, it also offers a few deprecations. So I'm sure you're all familiar with the async task class, right? So just in case you haven't already moved to other solutions for async programming, in Android 11, we've marked this class as deprecated. And one of the replacements listed in the documentation is the, well, kind of cryptic Kotlin coroutines utilities, which is, of course, Kotlin coroutines. So we've recently announced that coroutines are the recommended solution for async code on Android. And for some time already, it's been our focus to explore and deliver solutions based on coroutines in the form of new APIs, samples, code labs, and documentation. In fact, many people in Android are falling in love with coroutines. But why? What's so special about them? So I try to keep the list short as we're going to discuss some of it in more practical examples. However, the unique properties of coroutines make it especially well-suited for Android. Structured concurrency helps developers scope the work to the application component's lifecycle and prevent memory leaks. Then callback-free top-down code is much easier to read and understand. Cancellation support and natural exception handling make a great addition. And finally, many coroutines can run on a single thread, suspending their work instead of blocking, making them fast and lightweight. We actually believe in coroutines so much that we decided to put them up on our redesigned website as the 4th top reason to adopt Kotlin in your app. So check out our website if you haven't seen it already. Okay, let's talk about more practical examples. Let's look at some code. So a great API to look at is Work Manager from the Jetpack libraries, because it comes with all sorts of async flavors. The most basic one, it's simply called Worker. It already calls the method, so the work method, the one in which you do work, on a background thread. So you can do blocking operations like reading from a database or uploading to a server and then writing the result to a database again. At first glance, this code doesn't look that bad. It's easy to read, and it's quite explicit what it does. One problem is that we're allowed to do synchronous requests here. The moment you need to use an async API or you want to parallelize things, well, this can get quite ugly. And another problem is that Work Manager can order to stop the work at any moment. And while we could just add checks to every line of code, well, that's not really a great solution, but it works. But imagine for a minute that upload server actually does 3 long-running operations to complete. How do you pass this stop signal to it when it's in the middle of doing its work? Clearly, this example leads nowhere, even though it has natural exceptions and easy-to-read top-down sequential code. Okay, let's try something else. Another way of dealing with asynchronous requests are features. For example, using listenable features from the Guava library. There is another version of our worker that's called listenable worker that expects exactly that, a listenable feature. So let's see how this would look like. So let's assume we have some background executor of type listening executor service, and we want to submit some work to it as a Lambda. Then we get a listenable feature of data back. Now, for chaining the next operation, I look up the correct utility function, transform async, then make it depend on the previous one. Submit a Lambda again, get listenable features back. I'm more there just explaining how all of this works. It's really not ideal, right? But the nice thing of this is that we get cancellation and error propagation. What's nice and nice, it's actually all of this. It looks so difficult to find the actual work that I need to do in all of this boilerplate code. So for completeness, let me mention that there's also an RX worker available. However, that comes with drawbacks such as having to learn RX Java operators. And it simply can't escape the Java programming language's limitations, like having to chain calls, making everything else less readable. And finally, we get to the coroutine land with the coroutine worker. I assume here that our database and HTTP client provide suspending versions of their APIs, meaning it's suspending calls all the way down. Everything looks sequential and is readable. Cancellation happens more or less automatically, as it was handled by the library authors. Errors propagate naturally, so we can just use try-catch as in the first example if needed. So am I here to just say that coroutines are simple? No. I think they're ingenious, I think they're elegant, but they're fairly complex underneath. What we can do as developers is first and foremost educate ourselves, educate our teams. There is great technical documentation for coroutines from JetBrains on the kotlinlang.org website. But we also produced a ton of developer materials recently for using coroutines on Android. Articles, videos, collabs, and samples make it easier to understand what's going on in addition to the documentation. So pick the medium that you prefer and dive deeper in that. But even then, I believe that the whole trick of making coroutines simple for the user, in this case, the developer writing application code, is to move the ecosystem forward. We have a huge job to do here by providing the necessary plumbing behind each API and the necessary tools to seamlessly work with coroutines. As in my example, I assumed I have coroutine versions of the APIs I needed, which enabled me to write 3 lines of code instead of 20. But fortunately, all of this is already happening. We've already started with the most popular Jetpack libraries, with more to come. So going back to our example of reading from database, let's talk about for a bit. Reading from the disk, in this case, database queries, is a great example of one of the many things you should not do on the main thread. A room is an example of a library that gives you a suspend version of its calls out of the box. Other libraries are already adopting a similar approach, including third-party libraries like Retrofit. And What's really nice about this is that this suspend function is main safe, which means that it's safe to call from the main thread or the main dispatcher, as it will not block the thread. The library takes care of moving execution to the background and returning the result. So this might not sound like a huge deal, as someone could just make a with context dispatchers.io call inside a view model scopes themselves. But the fact that it's not needed reduces that cognitive load and reduces the chance of error from the API's consumer. So when you are building a library like this, make it the library responsibility and not the callers to change the dispatchers. Vroom actually does another thing well, and that's not only providing sane defaults for the background executor, but also giving you a way to change it. This will not only come useful if you want to share some executor that you already have in your app, but it's especially useful when you need to replace the dispatcher for testing. And by the way, Vroom is a Java library, so it takes executors, but their role is almost identical to the coroutine dispatchers. So naturally, there are methods to translate between the two of them. So what if you build your own API? Well, if you build your own API, you can do something similar by not hard-coding one of the dispatchers into the functional call, but rather make sure you make it configurable, making it easier to use for complex cases as well. Usually, though, you won't be building your API from scratch. Maybe you have a Java-based library already, or you're trying to adapt a third-party API surface to coroutines. Well, in those cases, there are two options. The first one is to check if an adapter is available in coroutines for the future types used by the library. There are integrations for Java 8 completable features, Guava listenable features, and tasks used by Google Play services. If you don't find an adapter, it's usually really easy to write your own, and this is the second option. So use the suspend cancelable coroutine builder function and call the continuation resume or resume with the exception methods from a callback. Of course, simple doesn't mean it's not possible to make mistakes, as I actually learned when I tried to test this code. As it turns out, I missed one important part. So for my API, I should have added a fast path. So I don't have any case when the task is already completed at the time of the call. So it works almost the same as the previous version, but it might solve certain problems when running this as part of a unit test. So for the full solution, I suggest you take a look at the code of any of the adapters in the Kotlin coroutines library. Okay, so I talked a bit about one-shot suspending functions that simply return a result. Let's move on to something a bit more interesting, flows. In the previous section, I've drawn a parallel between futures and suspend functions. Flow extends this by offering the possibility to model streams of data, not just single values. And it builds upon the foundation of coroutines and suspend functions to inherit some of these best practices or best properties, such as cancellation, structure concurrency, exception transparency, and even natural back pressure handling through suspension. Okay, going back to our Vroom database. With a simple change, I can make it return a flow instead of having a suspend function that returns a single result. And then observing a flow lets the app react to changes when the database emits new data. So how is flow different from any other observable streams, such as RxJava? Okay, well, conceptually, it's not really that different, other than having whole stream processing built on the same coroutines foundation that I've mentioned before with all its benefits. Okay, but you'll ask, how is this different from LiveData? The original Colab code that you find online, for example, the Room with a View Colab, uses LiveData to observe state changes from the UI. So short answer in the differences between LiveData and Flow is that when you're just observing data, there is little difference, but the full answer with more complicated cases is, well, it's a little bit more complicated. So let's see what this means. So conceptually, LiveData is a value holder. It always holds a single value that can be written to and read at any moment. What follows from this is that when an observer connects, it will only see the latest value and any of the new ones, even though there might have been intermediate values emitted when the data wasn't observed. So what's important is only the current state. A flow, though, doesn't have a value outside of being collected, and it will deliver all the values emitted into it, unless it's configured differently through operators such as conflate, which is a strategy for dealing with consumers that are slower than the producer. If we speak about a simple app that just wants to display data from on the UI from the database, well, the UI might not care about any previous states. It's only responsible for showing the latest. So it's fine to use LiveData. But Flow can be more appropriate in the lower layers of the app, where maybe for other operations, you cannot afford to lose some values. Then the latest Kotlin library version added the state flow, which does hold the current value, like LiveData. The main differences are, of course, that state flow is a flow with all of its operators. LiveData has other drawbacks, such as only being able to be observed from the main thread. So, what's the future for LiveData? It's too early to say. You could certainly continue using it or try replacing some of its usages with state flow, although that won't currently work directly with if you're using data binding, for example. So we're exploring this topic, and we're working for recommendations. So stay tuned. Okay, but the best part of Flow and LiveData is that you don't have to pick one over the other. As actually, it's very easy to convert from regular flows to LiveData and vice versa, which actually brings me to another topic. You may know about view model scope, a coroutine scope that is active as long as the view model is active. Similar to it, we have lifecycle scopes for activities and fragments. So knowing that LiveData is active when the lifecycle owner is at least started, and that we can convert between Flow and LiveData easily, what's the difference between observing a LiveData in an activity and collecting a flow when the activity is started? Well, the first one, using Flow as LiveData, cancels the flow collection when there are no active observers, which means when the activity is in the stopped state. The second one uses a pausing dispatcher, which pauses execution when the activity is not started, but only cancels the coroutine when the activity is destroyed. This is stated in the documentation, but to be honest, it tripped me up when I first used it anyway, and I have to go back to the documentation from time to time. If the flow can handle back pressure, that's not a problem, but not all flows are created in the same way. So let's see an example of this. So similar to how you can convert single-shot callback APIs to suspend functions, callback flow is a builder function that lets us convert callback or listener-based APIs to a flow. So here we take Android's location API, which will keep sending us locations while it's active. The source of our data is hot because new listeners don't trigger the location API init code. But our flow is cold, which means that the builder block will be executed every time this flow is collected. And a separate instance of the location listener will be installed. If we combine it with the lifecycle scope's pausing dispatcher, this will not work as you might expect. When my activity is visible, the collecting coroutine is active and updates the UI, while the producer coroutine that listens for location updates supplies the values. The interesting thing happens when I launch another activity. The current one is not destroyed, and so the collection is not canceled. However, it does go into stop state, so the consumer that is now suspended no longer processes any values. As the flow hasn't been canceled, the producer coroutine keeps churning in the background, getting locations and putting them in the flow with no one reading them until I come back to the first activity. Okay, so this means that we're getting locations and putting them in the flow again and again, wasting both CPU and battery, and it could even start filling up the memory if we configured it improperly with an unbounded buffer. So handle with care and learn how things work underneath if you start building your own flow solutions. Okay, there's one more thing I wanted to mention, and that's shared flow. Next to state flow, this was another highly requested feature for flows. And this is to be able to take a flow and share it between multiple subscribers. In the case of our location flow, for example, creating a new flow is not that bad because we're just registering a listener to the location API. However, it's very useful in other situations where the flow is more expensive to create, or if you want to save resources by sharing it. What's interesting is the while subscribed option, which will free up the upstream producer whenever there are no subscribers. But that's something that's coming in a future coroutine release, and yeah, we'll explore it more when it's ready. So these are definitely interesting times in Android development. Did we find the holy grail of async frameworks? Maybe. With the recent additions like Stateflow and shared flow, we can see that things are still in flux. But I think that's a good thing. The thoughtful, intentional design by the coroutine authors that responds to concrete use cases is what gave us what we have already. And it's a great fit on Android. So if you're deciding on async solution for your next project, give coroutines a try and let us know what you think. Thanks for watching, and let's see if we have any questions.
So it seems there are a couple of questions, Florina. The Raptorel has asked if you could talk about RX Java or RX Kotlin and how they compare with coroutines.
I think I kind of mentioned this a little bit when I was talking about RX, like right here. That conceptually it's not really that different other than having the string processed. But if you're talking about, I don't know, performance or stuff like this, I'm afraid I don't have any data on this.
Mm-hmm. Okay, well, if Raptor, if you have any particular question, feel free to write it. Otherwise, next one comes from Ravi Rawal. If you could elaborate on the being main safe and whether that means that they work on the background on the of the main thread.
Oh, yes. And if this was also well, wait. If they are main safe, was this referred also to, so for example, I think some of the examples that I gave were around Room, right? And the fact that the work that Room is doing with suspend or flows is main safe because under the hood, the library actually changes dispatchers. I think if you're not talking about that part, but rather you're talking about when running something in the main dispatcher, I guess that's the difference between threads and coroutines, that they're suspending, they're not blocking the thread. So I know that in theory you could be calling something on the main dispatcher, but you still shouldn't. That's why we have multiple dispatchers to use them when, depending on the work that we have.
Okay, I think we can take one more question. There is more questions from Ravi Rawal. So, for example, the next one would be on whether we should use a state flow as a replacement of a single live event.
I think the single live event was never like an official solution. I think it was something that we came up with from in the samples. I think it's an option, but I would say even single live event, in the end, we weren't able to find the best way to bring it in the official LiveData library. So I would say you could try it out and then see if it satisfies the needs you have from the single live event. So try it out and let us know. And maybe actually Jossi has some input on this, given that his talk is going to be around LiveData and flow.
Yeah, that's true. I think probably Jossi has also some inputs on his talk on the topic. I think that's probably good for now. Thank you so much, Florina, for making the time and being with us. If you folks, any of you have any question, I guess they can probably follow you on Twitter, and you're frequently talking about Kotlin and Android and coroutines. And otherwise, I would suggest for Jossi to come into the as the next speaker.
Cool, let's try this. I think I just gotta go live with my slides and then we're good to go.
Great, then if you share your screen, I'll add it to the screen. It should be already there, right?
All right, perfect.
Great, so yeah, just is your turn, and he will be talking about migrating LiveData to the algorithm. Everything yours.
Damn it, you took the first 10 seconds of my talk. I was trying to gain time. So hey everyone, welcome to this meetup. I'm super happy that you all managed to join us. I'm Jossi and I do Android at Snap Mobile, and we're this kind of consultancy / agency thing. And recently we joined a project that had kind of convoluted code, I want to say. It was a bit kind of all over the place. It had things all over the place, and specifically it had LiveData all over the place. Like, it was really, LiveData was everywhere, which is, I don't want to be there and go in and judge or anything, but we went into the project and we were a bit confused because we had really never seen this approach before in practice. But we were like, okay, this is fine, whatever, right? It's just LiveData, that's cool. And then a couple of days went by and we found ourselves into the project and we realized, ooh, something is going on. There are UI thread blocks all over the place. And it turned out there was something which, just in the design of LiveData and the usage, like the combination of those two did not work together well. So this talk is about our experiences made from this. So first off, I do know we're at a Kotlin meetup, and can I get a quick hand in the chat on do you know what LiveData is, or no? I can't see anything. I'll just explain it anyways.
Right, it takes anyway like 5-10 seconds delay. So if you ask a question, it might require.
That's cool. I just assume nobody knows LiveData, or everybody knows LiveData, but that's fine. So basically, the setup that we found in this project was, so we had this fairly standard Android setup for 2019, 2020, which is we had the UI layer, view model, and the repository. So every async communication between those layers was happening with LiveData. So for example, when you were writing to the database, or when you were reading from the database, or reading from the cache, or making a network request, just really anything that was async was using LiveData. So LiveData is an observable data holder class. That's like the basic summary. So it's an implementation of the observer pattern. And you saw some info from Florina earlier on this. So basically, we just have, for example, our view model, and we would have our mutable live data. And then in some method, we would fetch some data and post data to that live data. And in our fragment, we would just observe this using the view lifecycle owner. So this is great. Live data is great for a specific reason for Android development, because it's bound to the Android lifecycle. So you really don't have to worry about unsubscribing, and you don't have to worry about leaking things all over the place, which is super, super great. You get that for free, so that's really, really useful. So live data is awesome when used properly. This is not supposed to be like a talk, just riffing on live data and saying, oh, live data is horrible, because it's not. It's super awesome when used properly and in the right places. So I want to have a quick detour into live data and execution context. So here's an example from what we had. For example, our supermarket repository. And we had this function, fetch opening hours, and it would return a live data with opening hours information. So this was really just a one-shot function. So it would really just fetch data from the network and return that. And even using live data for this is overkill, but still it was using that. That's what we found. So in our view model, we would, have another function which used this from the repository. So what you can see going on here is we're calling the method from the repository, supermarket repo.fetch opening hours, and then we do some data transformations using the map extension. This is provided by the lifecycle KTX artifact, live data KTX artifact, and it's very, very useful. And we thought, okay, this is great, right? It looks great. And then we started looking kind of more into it and what's going on under the hood. And turns out there is a small caveat there, which is the execution context. So Green is saying, all right, this is happening on a background thread. So we were especially making sure that our fun fetch supermarket opening hours would be called in a background thread in order not to block the main thread with any long-running information operation or something. And everything was great in the next line as well. And this is what we would expect, right? So that just everything is happening on the background thread. But it turned out that actually the execution context was switching. So this lambda that we passed to the map function, it would suddenly be called on the main thread. And this was a little bit surprising. And then, so we did took a quick look into the documentation. It's useful if you can read, after all, and it turned out, oops, there's something going on. So let's take a look at the function, like this kind of map function that's behind this. So this is just directly from the AOSP source code. So the first thing you're doing is you're creating a mediator live data, which is basically a live data which can, as the name says, it can mediate between two live data. And then you tell it to add a source, which is this source live data. So if we take a look at our map function, that would be fetch opening hours, the source that we pass on. And then we pass this lambda right here, the red block. So we add the source to this mediator live data. And then when the source emits a value, this lambda in here gets called. And we basically set the value of this mediator live data. And in the end, we return this mediator live data. So basically what the map function does is it creates a new live data object given the source, and for every event or for every value that is emitted, this map function gets called with that value. So we can do data transformations. So in the design of LiveData is that every observer will be called on the main thread. So events for LiveData are dispatched on the main thread always. This is by design, and it's totally fine for a lot of the use cases. Man, Alejandro, you just stole my talk. I can stop you now. So events are always dispatched on the main thread. And this is great, but it can be a little bit confusing. For example, when you have a data transformation and looking at this code underneath, you're seeing, oh, this is why it switches to the main thread suddenly. So we were kind of presented with this huge code base which had UI thread blocks all over the place, and our first kind of lesson is, damn, it's really easy to let things slide when using LiveData outside of the UI layer and outside of view models, right? When you're using this for data transformations and more complex use cases, which it's not really thought for, but kind of has been used for. So we were presented with basically two options. Either we'd replace LiveData, or for all those data transformations, we would make sure threading is done properly and we would no longer block the main thread, which was not really easy for this huge thing we got going on. So we decided to actually replace LiveData. Well, first we took a look at, is it possible? But then our opinion was replacing LiveData would be the best way to go, and that is for everything between view model and repository. So those communications, those async communications, we decided to replace them. This doesn't affect the communication between view model and UI. So replacing LiveData, we had basically two cases that we needed to replace. Number one being what Florina mentioned earlier as well, is one-shot functions. So really just things that emit only one value. I think it's kind of obvious to everyone that using the observer pattern might be nice, like using the observer pattern for everything might be nice for consistency, I guess, but for just things that only emit one value, that's super overkill. If you're using Rx for just returning a single value, that might be probably is overkill as well, right? So it doesn't matter if it's LiveData or Rx, but still. So we decided to look for a simpler solution, and seeing that coroutines have recently become officially embraced and recommended by the Android team, we decided to go for coroutines because we worked with them in the past and they are a lot simpler. I mean, you saw some examples in Florina's talk as well, and it's just so much nicer. And I bet a lot of you are using coroutines anyways. So it doesn't really hurt to go there. Then we had the other cases with kind of streams of data, like actual streams where we had multiple values. We'll get to some use cases for that later. We decided to go for flow just because we were already going for coroutines, and we really wanted to have something that's consistent, and flow is being used in a lot of places now, and we had used it before as well, and we made some great experiences with it. So now it was actually about how do we convert this huge mess and how do we clean this up? So kind of the context we were in was that we were in this project which had huge time pressure, which is why the code had been convoluted in the first place. And we were in the middle of everything, trying to clean that up, which is not exactly fun. I guess you all know that situation. And so we were under time pressure and had to migrate in a graceful way. So converting to coroutines, fun exercise number one. So I know this is a lot of code, which is also kind of the point of the slide, but I want to show what things look like. So this is a repository with live data, and we were also using callbacks for example, retrofit requests, which is not exactly great. So the first action we took was to strip out all the callbacks we could and replace them with coroutines. Now this isn't like totally live data related, but I still want to mention it because if you take a look, it did so much for our code. So basically now you can see that all we're left with is creating live data, fetching the data, posting the value to the live data, and returning the live data. That's already so much better than what we had going on before. All thanks to retrofits, coroutine support. So yeah, if you take a look at the actual work that's happening, like in this function, apart from creating all the live data and posting the value, then you see it's really just this simple, right? It's just one line, just delegating to the retrofit interface. So what we did was extract all the logic. Sometimes we maybe have some more logic and do some data transformations already in the repository, or call some other repository with it and just help some other dependencies. And then once we had extracted all our kind of logic related to coroutines, we created migration helpers. So those are functions as well. And where before we had fetch opening hours, which would return live data, we now would have fetch opening hours, which would be just a suspending function. And we would introduce fetch opening hours as live data. So we just introduce this helper and append as live data to every method. And we use this awesome live data Lambda builder. So this basically allows you to build a live data really, really simply with a really nice API that's super similar to Flow as well. We'll get to that later on. So what you can just do is you can get your data, you can call any suspending functions. This whole Lambda in here, right? This is a coroutine Lambda as well. So it's a suspendable Lambda as well. So you can just really go in and use all your suspending functions, which is awesome. And then finally, you can emit data. So just creating a live data, but in a nice way, instead of first creating immutable live data, then fetching your data, and then posting the data to that live data, which is already a tongue breaker. So you don't want to write that in code, really. Finally, we annotated our methods with a deprecated, only the live data one. So we said, okay, this is a deprecated, don't use it anymore. And the nice thing is now, this was in our repository. So when you would go, when you would go into your view model, we'll see that in a second. So it's clear to everyone, like you can see this is deprecated, you should definitely not use this anymore. If you're writing new code, go use something else. Right. So the original reason, we didn't take care of the original reason for us to switch, which is the execution context, right? So this is still kind of unclear. So what's going on? It turns out that by default, actually, this is being called, like this whole Lambda is being called with the main dispatcher. So it's called on main thread, which we wanted to avoid. But luckily, the live data builder allows you to just pass in a context, the coroutine context. You can just say, all right, I want this to happen. I want this to be dispatched from this dispatcher. So we specify, all right, we want this to happen from the IO dispatcher. And then everything inside the Lambda happens on the background thread, which is exactly what we want and what we need. And now we have kind of a lot better control over this, which is super, super nice. So yeah, this is how we migrated our repositories, but then we still had the view models, which were, right, in some places still using the old code. So where before we would have like repo that fetch opening hours, that wouldn't work anymore. So we first replaced that with, right, those migration helpers that we introduced. So fetch opening hours as LiveData would be our new call. And then due to having annotated our method with @deprecated, the IDE highlights it like this. So it actually like has strike through, so you can see, oh, this is bad. You probably shouldn't be doing this anymore. So great. First thing, migrating to coroutines done, kinda, because we still had the map call. And this stuff, right, this whole Lambda is still being called on the main thread because of just what we explained, what we looked at earlier with the map function and mediator LiveData and observers being called on the main thread always. So what we decided to go for as a next step to totally migrate to coroutines was to shift the usage of the LiveData builder into our view models. So this migration helper, we basically just pull it over into the view model. So now our function fetch supermarket opening hours would directly use that builder, that LiveData builder. We still specify the context and say, hey, please run this on the IO dispatcher. And then the whole Lambda will be happening, will be called on background thread, which is what we need. And so we fetch the data from the repository. We use our newly migrated coroutine function from suspend function from the repository. And then we just directly filter our hours, what we before had to do with a map call. And finally, we emit the data to our LiveData. So now this can just be used from anywhere in our UI layer. This is also super nice because we just got rid of the map call. And I really like getting rid of things like that because it usually makes your code more complicated to understand and just harder to understand, more complicated to read. So this is really, really nice that we were able to simplify our code like that. So the other thing that we have left was like actual streams of data. So where we decided we want to convert to Flow. So this is what our code looked like with LiveData, which is right kind of similar to what we saw earlier. So first we create a LiveData, immutable LiveData, and then we look up our cache. We wanna see if we have something. And if we do have something in the cache, if it's not null, we post that to the LiveData. And then we download our fresh details and finally emit that. And then we return the LiveData object. So again, this is happening in the repository and was kind of not great and not super, super nice. So we decided really to go for a similar approach with the migration helper because that had worked really well for us. So first, we did just change the return type to flow of supermarket details. And then instead of using the LiveData builder like we did earlier, we used the flow builder, which is actually just basically the same API. It's really, really similar, which made migrating also super easy. And then in there, we just had our actual logic code. We emitted data if we have it, and that was it. Kind of, right? Now we had a nice flow, but what do we do with our existing code that relies on LiveData to work? So in our repository, so we again created this kind of migration helper where we said, okay, we exposed some LiveData similar to what we did before. And the awesome thing is there are extension functions, Kotlin extension functions, which you can call on a flow or also on a LiveData. You can just say on a flow as LiveData, and that gives you a LiveData instead of a flow, which is super awesome because we were able to kind of cleanly encapsulate all our things with the flow helper, with the flow builder. And then we would just provide this fetch supermarket details as LiveData, where we would really just call as LiveData on the flow, and that was it. And similarly to the LiveData builder we saw earlier, you can also specify the dispatcher right there. So we make sure that this flow builder lambda that we had before, it would also get called on the background thread. We also annotated those with a deprecated, right? Just again to make sure to everyone, please don't use this anymore. Yeah. So there are some additional resources I would want to point to, which are just the Android developer's documentation on LiveData. It does have a lot of the information, and I still would totally recommend using LiveData for any communication between the view model and the UI layer. That works really, really well. It's been in use for a long time, so it makes sense to use. I wrote a post about the kind of backgrounds of not using LiveData in repositories recently. So go check that out. And then Roman Elizarov also wrote a post on the execution context in Kotlin flows, which you can find under the last link. So that basically looks at what we did with flows, which is for LiveData. The great thing is that for using flows, the things are just controlling execution context is a lot easier. I did not want to do a deep dive into that since this post is a very, very good job at it, but it's a lot easier. And I would definitely recommend using flow over LiveData for everything that's kind of not touching Android things. Yeah. So thanks all so much for joining. Here's another dog picture. And yeah, if you have any questions, shoot, I saw there are some questions going on, so maybe we should go from the top.
Thank you very much, Jossi, for making the time, and nice talk. There are actually a couple of questions that people have been writing here. So, for instance, Bratislav is asking whether we should use Kotlin.result with flow, and whether you have any experience on the topic. And he has a follow-up question on how do you handle errors?
Yeah, that's a very, very good question. So before in the code base, we were using a custom type, which is similar to Kotlin.result, just a sealed class. But basically, we made some efforts with this whole migration we did. We made some efforts to use Kotlin.result in there as well. And we made some nice experiences with this, like the functional aspect of this. But I'm not sure how that changed with Kotlin 1.4, but it's still kind of in preview and very open to change. So what we did instead was just have our own representation similar to Kotlin.result. But I would definitely recommend looking if you can use Kotlin.result. It's a really nice API, and I would definitely go for this as the main first way to do error handling and do results in flows.
We have another question from Raptorel. Is there a code lab covering those things?
Well, I don't work at Google, but I do know that the Android developer advocacy team is making some efforts to kind of improve that. And I think they're working on some things. I just see there is something apparently. Florina is saying yes. Maybe we can get her on the line.
Yeah, hey. Yeah, so we have, I don't know if the question was specifically about switching from LiveData to Flow kind of collab, but we do have different collabs around using Flow. So for example, I think Room with a View is kind of the simplest one that uses Flow and LiveData. Then there also is a collab that shows how to convert your callbacks to coroutines and Flow. So TLDR collabs, just look for Kotlin on collabs and you'll find resources.
Awesome, thank you so much.
Great. And maybe last one from Giuseppe Detri. Did you try Stateflow?
No, we didn't try Stateflow. Would have been too much of an effort. Try to clean up and migrate that as well. But I think it's definitely a nice thing to look into. Look forward to.
Great. Well, thank you very much again, Jossi. If any of you have any question, I guess they can reach out to you on Twitter. You're generally very active sharing your latest knowledge and what you learn.
Yeah. You can also find the slides there.
Great. If you upload them later, we can also post them in our Twitter account, retweet you from there, and also on the Meetup page.
Perfect.
Great. Then last but not least, mine will be a bit shorter, but I'll be speaking about what's new in Kotlin 1.4.0. Let's see if I can share my screen. So I think that's the. Well, now the funny thing is that I can't see what you see, but let me open shortly the YouTube video on another computer. Yeah, so looks good. Great. So yeah, I'll be talking about what's new in Kotlin 1.4.0. It came this version was released 3 days ago. There has been a few release candidates and beta versions that JetBrains was releasing. So more or less we knew a few things that were going to be included, but yeah, we could not know what was finally going to be there until the final version. I've been checking a few ones that I think are more relevant. Among them are new language features and improvements to the Kotlin. There has been some work on the tooling. The compiler has been also has included a few optimization things. This release actually has been from JetBrains categorized as a release focusing on performance and quality. So don't expect that many fresh features coming out from here. There has been a few new incorporations into Kotlin native, as well as the standard library has come up with a bunch of new functionality, as well as a stable serialization on JSON. This is not an intensive list. It came also 3 days ago. I didn't have time to check everything, but there is also, if you're interested, further work into the Kotlin, GBM, Kotlin for JavaScript, as well as Kotlin multi-platform, and some Gradle project improvements. That if that's something you are interested with, you might want to check the release notes from JetBrains, but I'll give you some links after. Before I start going with the I see, by the way, that I have those text slides everywhere. Yeah, well, anyway, I hope you don't find it very disturbing. Kotlin has shared some numbers on the people that has been editing Kotlin code for the last 12 months, and well, it looks a very nice production. I think if you're currently working on Kotlin and wondering whether this is the right direction or not, community usage of a technology doesn't mean the technological acceptance by companies, but I think it speaks very well of the state of the ecosystem. And there has been as well some improvements on the IDE. I want to show this before, since well, one could argue whether this is part of the Kotlin 1.4.0 release or not. But JetBrains claim that now is significantly faster when you're opening big Kotlin files. Before it could take a little bit of time until, well, all the styling was applied, and when you were copying code from one class to the other, it was not, well, it was taking a small amount of time. But now it seems to have been rewritten, and it's significantly faster than it was before. So without further delay, some of the new language features and improvements that come with this new version are the async conversion for Kotlin interfaces. before Kotlin 1.4.0 arrived, you could apply SAM, which stands for Single Abstract Method. There was actually a very nice post from Jorge Castillo. If you search for him on Twitter, you'll find him. So before, you could apply SAM conversions only when you were working with Java methods and Java interfaces from Kotlin. From now on, you can use those conversions for Kotlin interfaces as well. If you want to do so, you need to mark a Kotlin interface explicitly as functional with a fun modifier, as you can see here in this example. Before, if we were not using a SAM conversion, if we wanted to use the interface, we would need to write code like this, and it's a bit cumbersome and not so Kotlin-ish. Well, theoretically Kotlin-ish. It was done with Kotlin, but it was not what we were used as we were used to work with Kotlin. And if now with Kotlin 1.4.0, we can just use the short lambda expression that replaces all the unnecessary code. So this is how it would look on the big picture. We will have the interface, the function that uses with the lambda this interface, and we could just essentially have this example at the bottom where we print directly on one line. This is one of the features that I find more interesting. If you are, I guess there is this certain correlationship between Android developers and Kotlin developers, and there is this explicit API for library authors. This library, the Kotlin compiler offers this mode for people false writing libraries, and in this mode, essentially, the compiler will perform some additional checkups that will help to make the library API clearer and more consistent. So there are two requirements. The visibility modifiers are required for declarations if the default visibility exposes them to the public API. And explicit type specifications are required for properties and functions that are exposed to the public API. If we want to activate it, we just need to include this into our Kotlin configuration file. This is very useful, and if you've been writing libraries in Kotlin, I've been doing that recently. One of the problems is when you're when you're developing a library, there are some things that you want to expose, some things that are internal, some classes that you don't want to offer to the external app integrating this library, this module, and this explicit API mode just comes to solve this problem. There are mixing, now we can mix name and positional arguments. Before, in the previous Kotlin version, when you were Kotlin a function with name arguments, you had to place all the arguments without names. Those are called positional arguments before the first name arguments. For example, this thing from here could work, but this one from here would not work. And it was really annoying when all the arguments were in the correct positions, but you wanted to specify a name for one argument that was in the middle. It was especially helpful for making absolute clear which attribute a Boolean or a null value belongs to. You've had before all this, like this long, when you're calling this Java code, you have these functions or constructors that take some Booleans or nulls, and you don't really know which one is which belongs to which attribute or which not. Now with the IDs, it's a bit easier because you can see normally you have this small indicator saying exactly the name of the parameter, but Kotlin made it better with the name parameters. Now with Kotlin 1.4, there is no such limitation. We can specify a name for an argument in the middle of a set of positional arguments. And even further, you can mix positional and name arguments any way you like, as long as the order is still the correct one. So here we could have this reformat function that receives a string, a Boolean, and a character, and we can just pass them as we like, respecting the order. Trailing commas. Some people argue that this is the most important feature in Kotlin 1.4.0. As you can see here in the function reformat, at the end we have a trailing comma as well as on a list. And this is useful because if you are like some people, I particularly do that all the time. In IntelliJ, you can like just take a line and move it up or down as you are developing. And when you were using a lit on a function, of course, you always had to remove the comma from the last value, because otherwise it was not compiling. You were receiving an error, and this will solve this problem. So it's arguably the best new feature in Kotlin 1.40. We can use now break and continue inside when expressions. In Kotlin 1.3, we could not use the unqualified break and continue. The reason for that was because the keywords were reserved for some fall-through behavior in when expressions. So if you wanted to use them, you needed to have something like this. You needed to add the at loop, or loop at, for the for and the continue, and that was very ugly and cumbersome, and well, didn't play very well with the auto-completion, etc. Now you just can do it like that, and it will work out. So that's it's very useful. I guess if you've sometimes you've been in this situation when, well, in 2 I want to do something, continue, break, so now it's available. There is new tooling available. There is a new project, Wizard. It has been, well, you could argue if this is battling of Kotlin or not, but well, it's there on IntelliJ. When you're creating a new project with Kotlin, I think until now it was, particularly for multi-platform projects, it was relatively easy to end up with nothing, because you were creating the project, and then you, for this multi-platform, you wanted to focus on the mobile side of the things, or a library, or etc. And well, it was not so easy to get it done. I think in previous versions, even like it was not fully compiling the final project. But now it seems very straightforward. Here in this example, for a multi-platform project, you can specify if you want to make an application, a library, a native application, full stack web application, whatever. Yeah, that's. Then the new compiler, as I mentioned, it has been the new compiler has been focusing mostly on performance improvements. So there are more cases where the type is inferred automatically. The smart cuts have been improved quite a bit, have been now quite a bit improved. There is better inference for delegate properties, some conversion for Java interfaces when there are different arguments, and Java some interfaces in Kotlin, I mentioned before. So the type infer, how are types now inferred automatically better? So we can see this case from here. At this point, it knows that we are dealing with a string. For this case, we have a weak, so we can see if it's null or not. Medium, in this case, we can see if it's null or blank. And in this case, strong, we could see if it fills this regex pattern from here, and if it matches, then you print it. This, for example, will print true and false. So before we were not, we could not automatically infer that it was a string, and hence use these sort of rules here. But now it's possible. And also very interesting, it's this aspect of nullability. Before, with Kotlin 1.3, we could actually not know whether a string is optional or not. But now with the new compiler coming in 1.4, we're able to see that a string at this point cannot be null, because we have initialized it here. And hence, the type is a string and not an optional string. There is also a smart cache for callable references. So in this case, we have different member references, such as animal new and animal wolf. After the animal variable has been smart casted to a specific type cat or dog. After the type check, you can access all the member references that correspond to the subtypes. There is better inference for delegate properties. In this example from here, or before, the type of a delegated property wasn't taken into account when we were analyzing the delegate expression that came after the by keyword. For example, this code from here would not compile in Kotlin 1.3, but now the compiler is able to correctly infer the type of the old and the new parameter as an optional string. Now, Kotlin native. I'm particularly excited about what's coming here because it has been sort of a experimental feature that can really bring a lot of benefits for mobile development. I think is slowly moving forward, but definitely the direction is forward. And this release has included particularly a few things that help iOS developers to use Kotlin native. So now when you compile a Kotlin, there is support for Kotlin suspending functions in Swift and Objective-C. When you are compiling a Kotlin module into an Apple framework, these suspending functions are available as functions with callbacks. That's called a completion handler in the Swift terminology. When you have those functions generated in the framework's header, you can call them from Swift or Objective-C, and you can even override them if you want. Now, Objective-C generic supports are happening by default. Just as a reminder, until recently, they were not supported at all. So this is a really nice step forward. So we can still disable them if we want. So if we include this line on our Kotlin setup, we will not use we will not write generics, but by default they're actually being supported. There is a few performance improvements on Kotlin native as well. So my malloc memory allocator is now the alternative to the system allocator. JetBrains claims that according to the benchmarking is twice as fast. The scene interoperation libraries have been reworked, again, according to JetBrains, and now they are 4 times faster, and the artifacts are 25 and 30% the original size, and the overall runtime performance has been improved. There is no detailed description of this, but, well, consider that, I guess that means that the general KN Kotlin native is getting faster. Now, there are simplified Cocoa Pod dependencies. Before, when we were working with Kotlin native and in Swift and doing our Swift code, when we integrated our project with the dependency manager, we could build our iOS app or macOS app, part of whatever, on the project only on Xcode, separate from the multi-platform project, which was very inconvenient. And yeah, even more, when we wanted to install a Cocoa Pod dependency, we needed to jump into the console or run Xcode and build and create get all the pods from there. Now everything can be managed directly from IntelliJ without having to jump into Xcode, with all the benefits that this has, such as highlighting, code highlighting and completion. You can also build the whole Kotlin project with Gradle without having to move to Xcode. So that means that essentially you just need to go to Xcode when you need to write Swift or Objective-C code, all the Kotlin things. Everything else can be handled on IntelliJ. Now, the standard library. Kotlin is, JetBrains is slowly incorporating many nice things on the std leaf. They've been incorporating a bunch of things for collections, for example. We have now this set of not null. Essentially, we can just check from a set which values are null or not, and just take the ones that are not null. Shuffled, it takes shuffles random elements over a collection. There is this indexed suffix that we can add right now for functions, the counterpart functions such as on each on flat map. So instead of on each, we could call on each index and flat map index. Those functions apply to the collection element, the element index as a parameter. So here we see that we have this particular index, this attribute index over here. And it would be referring to as the index to which this element belongs. That's really cool, because otherwise iterating on each was not supporting that before, but now with this indexation, it's very convenient to access the position, the particular index of an element in a collection. There is this suffix or null that we can counterparse with reduce and random. And they essentially return null when a collection is empty. if we were trying to apply before in Kotlin 1.3 this the reduce function to an empty collection, we will get an exception because the collection is empty and it cannot be reduced. Now, if that happens, we just reduce a null, so it's very convenient. We have the sum of function. This is also really nice and really verbose for our usage of Kotlin. Let's see this example from here. We have we create a list of 3 items. They are a cake, a coffee. They have a price and account. We can actually get the total value of the all the orders by using the sum of. We just need to specify to the iterator that we want to multiply the price to the count. And we could get the total counter of elements by summing all the counts on our collection. Also really useful. And there is also a min of and max of function that allows us to access the minimal or maximal element over a collection, specifying the concrete value of the iterator. There are new functionalities as well from arrays. I'll not go into too much detail on them. We can now shuffle on each, associate with, reverse, sort descending, and sort. That was previously not implemented on arrays. And this is an example that combines them more or less on all of them. So for this array, we could just call the function on each, shuffle it, reverse, sort it descending. And this particular sample will take Kotlin as an array, do some modifications over it, and then we'll be able to bring Kotlin back. We have a new type, an array deque or deque. It's essentially a double-ended queue. It lets you add or remove elements both at the beginning of and at the end of the queue in constant time. So this can actually be used by default when you need a queue or a stack in your code. Great, more functions for string manipulations. String Builder now has set range, delete, and delete at, which was not previously included. And some of the String Builder functions are now available as well in the standard library, append, insert, and substring. Yeah, and that's I think doesn't affect too much the final users, but well, Kotlin serialization now is stable, and the previous we have this 1.0 version that is supposed to be stable. So if you're using serialization on any project, any multi-platform project, now it's expected to work better. Just as a side note, Kotlin is providing a tool to migrate from Kotlin to Kotlin 1.4.0. I checked it for a big project of mine and didn't work quite out of the box, but yeah, it definitely provided a lot of nice feedback when you were doing the migration. So don't feel you'll have this support from JetBrains, which I think is nice to have. Before finishing, I would like to. I saw this thing from Kotlin, from JetBrains. They are actually having a 1.4.0 online event where people can register and attend it for free. It will happen on the October 12th and 15th, and I guess they will go into much more detail on every single feature that has been actually released with Kotlin. So, yeah, I encourage you to check it out if you're interested. And this is a couple of links that can be useful. In the first one, if you search on Google what's new on Kotlin 1.4.0, you'll access this website from here. They explain everything a bit more in detail. Particularly, they go through the things I've even analyzed in this talk, the Kotlin JavaScript and Kotlin JVM and etc. and all the Gradle goodies. And the second one is a blog post where it's they speak a bit about well, not only the new releases, but what are they intend to do with Kotlin, what's the long-term vision of Kotlin for JetBrains, etc. So that's everything from my side. If you have any question and I know the answer, I will be happy to take on them. Liubomir writing a great summary, thanks. Yeah, happy if it was useful. Yeah, I think I didn't have time to check yet the Kotlin Particularly JVM and JavaScript is not something that I've been working too much with it, but I also want to check them out. But yeah, I think those are the things you can expect from 1.4. F2 growth, the compiler F speed improvements need Android Studio 4.1 Plus or IntelliJ 2 2020. Not really sure of the particular requirements of the IDE, but yeah, I can imagine that you need to update on to the latest version. Well, if you don't have more questions, I would like to add Jossi and Florina back to the stream. And yeah, thank you both for making the time and being part of the meetup. It's always a pleasure to have you on with the Munich community. Even if I have the impression that now the online meetups are not only for a particular region, right? Like I've seen here people coming from India or Spain. So, well, all of you are welcome, of course. We'll keep the name of Kotlin Munich while Corona is there.
Thank you for having us. Yeah, I guess that's the benefit of the virus, that it connects people from everywhere.
Well, yeah, if any of you folks attending the talk have any questions, I guess you can just reach us through Twitter or find us on Google, and yeah, we would be happy to support you with any questions or problems you have. Well, thanks again, and have a nice rest of the day. You're in European time zone, so just a few hours until you sleep.
Thank you.
Bye-bye.
Bye.